that reference sheet. And it should stand out as, oh, this is an identity. There is because we kind of know that tangent can become secant through this identity here. Let me snip this in. How could we use this identity?
So -1 so the secant squared x -1 equals tangent squared.
Right. So how are you going to do that? Where are you going to use that?
In the parentheses.
I'm sorry. Just to be clear. Are we working on the left side or the right side?
So the left side.
Okay. So what do you want to do with the left side? You want to replace the secant squared x with tangent squared +1?
Yeah.
Okay. So let's do that. So this becomes tangent squared x +1, secant squared x -1. And you've got matching things here, which is good. That's good news. This is the same as this. So that's good. So your focus should be on, well, either this secant squared or this tangent squared to make them into the other. Basically using the same identity.
+1. Well, the tangent squared x would equal secant squared -1.
Yes. And that's basically, now it's done. Secant squared x -1, tangent squared x +1. And this is it. It is done. Any questions on that?
No, pretty straightforward.
Yeah, that one's good.
A lot easier than yesterday.
Yes. Hence the level 3 or level 4. All right. Where should we go from here? What would you like to look at next?
60.
60. Okay. All right. So here's 60. Is one side more complicated than the other? Does one stand out to you to look at more than the other?
The right side.
Yeah. Now this has a particular form that you have to see. So there's really a ton that goes into just the word factoring here. Do you happen to see what type of factoring this is?
I feel like it's on the tip of my tongue, but
So this is a perfect squared trinomial.
yeah.
And it factors into a minus b squared like this. So a is the secant. Well, actually, it's probably easier to see in the middle term here. A is the secant, b is the tangent. Do you see that?
Yeah.
Okay. So this becomes, on the right, it becomes secant theta minus tangent theta squared, like that. But I mean, that is no way close to this thing on the left, but that is what it is. So does anything stand out to you? I mean, this is a good step to take, but does anything stand out to you from this point, what to do next?
Can you distribute the exponent?
That would go backwards. That's like going backwards to this. Because you would like this a minus b means a minus b times a minus b. I mean, like you could write secant theta minus tangent theta times itself. But that's not getting us anywhere closer to the solution. So what else? What else are you kind of drawn to here? If anything.
It's not a Python identity.
No.
I mean, the only thing I can think of is to make it a sine and cosine, but
Okay,
I don't
so
think.
let's do that. Let's do that here. So we'll actually work from this line here. So that's 1 over cosine theta minus sine theta over cosine theta. Okay, now what can you do with this? Now that they have the same bottoms,
You can combine them.
right? So make 1 minus sine theta, and that becomes cosine theta on the bottom. Squared, okay. Now is anything standing out to you? Because you should see something on the left side. I mean, like if you go back up, you have the 1 minus sine theta now. That's good.
Well, the 1 would equal 1 over 1.
We can't wait, like this is in parentheses. You don't want to manipulate that. And you have, because you have what you want.
Mm-hmm.
What if you were to square the top and bottom? So it'd be looked like this. This squared over cosine squared theta, like that. And remember, our goal is to get it to look like this. So we don't want to change the 1 minus sine theta. We really want to keep that. But maybe we can do something with the bottom. What can the bottom become?
Oh, minus cosine squared. Sine.
It's a
So it's
Pythagorean.
one of the, yeah, it's one of the identities. I'm just trying to figure it out.
So it's a sine squared theta plus cosine squared theta equals 1.
So would it equal 1 minus sine squared?
Yes. So we have 1 minus sine theta squared up top. On the bottom, you have 1 minus sine squared theta like this. Okay. You're really close, believe it or not. I know it may not seem like, but you're really close here.
Can you cancel the exponents?
No, because they're not the same place. Like this is outside the parentheses. This one's part of the sign.
How come you don't distribute the one at the top? It just stays there.
Because if you'd have to write it like this, and this is what you should do. Actually, you should separate it. That's what it means to square something. When it's two terms inside parentheses, you have to write them out side by side.
Oh,
And this is actually the next step, by the way. So what can you do with the bottom?
sine.
The bottom factors. It's a certain type of factoring.
Can't you make it 1 minus sine and then 1 plus sine?
That's right.
Yeah.
Good.
And then both the 1 minus signs cancel.
That's right. And now you have it. Well done. That was tough. 60, 61. Next one, dude. Just want to do them in order.
Yep.
Okay. All right. So I think you're clearly going to work on the right side here. Not much debate on that. What do you see? What makes sense to you to do here on the right side?
Would you try to get both the denominators the same?
Yeah, like I would look at it as 1/1 and 1/1. And yes, like individually make them the same. So
Oh yeah, then you do the reciprocal. Or not the reciprocal, but you multiply it by the opposite.
so what are you going to multiply this 1 and 1 by here?
Cosine.
You want the same bottom though.
Oh yeah, sine.
Sine. So it's going to be sine theta over sine theta minus cosine theta over sine theta in the numerator. What about the one on the left?
That's by cosine. So it'd be cosine theta over cosine theta minus minus sine theta over cosine theta.
Okay, good. Now what? This is all good, but now where do we go from here?
Oh, they have both the same denominators.
It really should just focus on, one of them, like just focus on the one on the left there. So it's supposed to be a square. Really just focus on this is what I would do. Not try to do both.
Can you combine the denominators?
Yes. Yeah. So to be sine theta over sine theta minus cosine theta over sine theta, like that.
So the signs would cancel, right?
Yes. No, I'm sorry. They do not cancel. No.
Oh yeah, because the top isn't a denominator.
Yeah. So it actually just goes to the top. It becomes sine squared theta over sine theta minus cosine theta.
So when the top doesn't have a denominator, the bottom just goes to the top.
Yeah, it's like this. It's like A over B over C. You multiply the top, and you really look at A, the top as being A over 1. Let me get this in here. And then C over B, C over B. You see how the bottom cancels. So whatever was on the bottom goes to the top. See how that goes to the top there?
Yeah.
That becomes sine squared in this case. All right, so now we really should probably go and do something on the right. This other fraction here, what do you see that can be done? This one over here.
So that would become cosine theta over cosine theta minus sine theta over cosine.
Yeah, like that. Okay, good.
And the cosine would go to the top, so it'd be cosine theta squared over cosine square or cosine theta minus sine theta.
Yeah. All right, now from here, it's not looking great, but you're getting closer. The denominators are not the same though. So you can't just combine them. You have to do something before you can combine them. Like, do you see how it's sine is positive and cosine is negative, but over here it's cosine is positive and sine is negative.
Yeah.
So you can't work with that directly. You have to take a negative out of one or the other. Doesn't matter which one, but I would recommend taking the negative out of this one on the lower right. So let me show you that. If you take a negative out, it becomes negative cosine theta plus sine theta, like that. Is that clear?
Yeah.
Okay. And then that negative goes up to the top, like it's gonna take the place in the middle between the two. And so then you just rewrite the bottom as sine theta minus cosine theta, like that. Is that okay?
Yeah.
All right. So now what can you do?
Like you can combine them now, right?
Yes. Yep. Sine squared theta minus cosine squared theta over sine theta minus cosine theta. So really, again, like probably good to take a look at the left side, be like, okay, what are we trying to get to? Because we're kind of down a rabbit hole where make sure we actually know where we're still going. I mean, you're really right there. Like the answer is you're one step away, I'll say. I mean, you're right there. It's related to the last problem that we did. It's kind of what you do at this point.
So it's sine squared. Yeah, you do the same type of splitting everything apart.
What do you mean by split apart? Give me more explanation on that.
So it become hang on. Sine squared theta minus cosine squared theta. So would it become sine plus cosine times sine minus cosine?
Yes, it's difference of squares in the numerator. Sine
Yeah.
theta minus cosine theta, or you can do plus if you prefer. But yeah, that's the key thing to see here, because you've got the answer right there. Minus cosine theta, and then they cancel, and there you have it.
There we go.
All right, so let's go to 62. Okay, so probably in agreement, the left side's more complicated than the right.
Yeah.
it's quite a bit more complicated as well. Uh, I like the thing that you really want to notice from a, kind of macro view is that there's no fractions over here on the right. So that should be something to look at right away. There's no fractions. So what should we do to the left?
Can you multiply both the fractions by the reciprocal of the denominator?
The conjugate, I think you mean.
The conjugate, yeah.
Yeah, yes. And that would be a good move here to do. So 1 minus cosine theta, 1 plus cosine theta, sine theta, cosine theta. And then we've got 1 plus cosine theta. Sorry, I need to do the top and the bottom. Lots of writing here. Yeah. So can you tell me what the denominators become on both sides?
So on the left side, become 1 minus cosine squared theta.
Yes. Now, can you see it? Well, let me write that out. Oh, sorry, the right is also 1 minus cosine squared theta. Okay, so from here, anything stand out to you? Anything you're noticing?
Um, hmm. So you can't distribute the parentheses, right?
Not yet, not yet. Because your bottoms are the same, but there's one thing to do before you combine the fractions. Remember, we were trying to make a common denominator so we get rid of the fractions to match the other ones.
Oh, wait. So can both the bottoms become sine squared?
Yes, and that's what I would do next. And there's a little more to that. What does that allow you to cancel with when you do that?
Yeah, let me write it down. The signs cancel on both of them.
Yeah, one of the signs cancels that one, canceled that one canceled that one. That's really good here. So you got 1 plus cosine theta or sine theta minus cosine theta, 1 minus cosine theta over sine theta. And it might be good to go back and just revisit what we're trying to get to. The whole goal here was to get rid of the fractions because there's no fractions on the right.
Um, and this one. Um, I know you have to get rid of the denominator somehow.
You just combine them. You just one
Oh
plus
yeah.
cosine theta minus cosine theta times one minus cosine theta. I mean, that was the whole goal here, is you gotta eventually get rid of like have one fraction, because one fraction will benefit you here. Maybe it's not apparent yet, but you can do some things now when you in the numerator. So the numerator's got to get your focus next.
Um, can you distribute the negative cosine theta?
Yes. So 1 plus cosine theta minus cosine theta plus cosine squared theta over sine theta.
So both the cosine cancel.
Yeah, and I feel like we lost something here, or I lost something, because that gets you. Oh no, I'm sorry. That we're almost there. You're right. There's, yeah, 1 plus cosine squared theta over sine theta. Let me bring that. Just post that in again. So you're so close. Like, you have the 1 plus cosine squared theta.
Uh, well, you'd have to split it to get cosecant because cosecant is 1 over sine.
So think of there being a 1 over here on the left.
So that'd just become 1 over sine.
Yes. And that becomes the cosecant theta.
Yeah.
So good. Really, these are tough. Sometimes it's that last step where it kind of all falls in. All right, 63. I guess we're up to 63 now. So the left is obviously more complicated than the right, but does anything stand out to you on this one?
Um, you can you can't factor them because all the exponents are the same.
You can the top is factorable. It's difference of squares.
Yeah. So the bottom.
Don't forget about the bottom for a moment. Just the top though. What can the top left factor into?
Um, secant squared plus tangent squared times secant squared minus tangent squared.
Yeah, exactly. And that's critical here because that basically ends the problem. You've got everything lined up now. Like this. And they cancel.
Wow.
And here you go, you got it. I mean, there are some that are that easy, that straightforward. '64, I think, is like that, where it's like one move kind of checkmate type of thing. If you play chess, it's really kind of frustrating if you're the opponent, but I think we're going to work on the left side here. So something about the left side becomes the right side. You should notice again, there's no fraction on the right, so you probably have to do something to the bottom. Anything stand out there when you see that?
Um, well, 1 plus cotangent squared equals cosecant squared.
Yeah, that's probably that's the right place to start here. Is cotangent squared t minus 1 over cosecant squared t, like that. But that's not enough here. Anything else stand out? Not in the numerator.
Cotangent squared minus 1.
It's the same identity. You want to use the same identity because look, you got to get a 2. You somehow got to get a 2 here. That's why it's, you guess you still got to do something.
Hang on, let me just write this out. Hang on. So 1 plus cotangent squared theta equals cosecant squared theta. I'm kind of stuck.
Okay, so let's substitute in for cotangent squared. Okay, so cotangent squared on the right is now cosecant squared theta minus 1.
Yeah.
So and that's what I was trying to allude to is the top, it becomes minus 1 minus 1. That gets you the 2 that you're looking for.
Oh.
You got to somehow get a 2 at some point. That's kind of another strategy. You try to get the thing that you got to look for. Those things can help.
Um,
Okay, so we've got cosecant squared t minus 2 over cosecant squared t. And keep an eye, on where you're going. What's on your target here? Your target is to make it look like 1 minus 2 sine squared t. Let me snip that in. Yeah. So you got the 2. That's good.
Um, would the cosecant on the bottom become 1 over sine squared theta?
It does. You're kind of getting a little bit further away from it. Do you see how there's 2 terms here on the right?
Yeah.
Well, if you divide each of these, you get 2 terms. And you get the 1, like cosecant squared over cosecant squared gets you the 1.
Oh,
And then what you just said applies to the one on the right. So again, just writing out here, cosecant squared t over cosecant squared t minus 2 over cosecant squared t. So the one on the left becomes 1. And then the one on the right, you got to decide, do you want to just, you can literally just say it's sine squared t. You don't have to show anything. But if you want to, you can write, like you just said, 1 over sine squared t. And then, it's the same thing we talked about earlier where that comes up top. Then you have it.
okay.
Okay, so new problem here. And by the way, if we've worked one of these before, we might have worked it different.
Do any of these really have multiple ways of doing it?
I mean, really, you can work on each side and or both sides and all of them. There's sort of always like this might be better than the other. But yeah, does anything, like when you look at this one, does anything stand out? Any?
Um, would this be a both side?
Possibly, yeah. Because I see some stuff I want to do right away to the left side, like with identities, but I don't know if it will. I don't know if it will work. What about the right side? What kind of do you see on the right side?
Um, we had this earlier.
Yeah.
It's a type of factoring.
No factoring on the right yet. There's nothing you can factor.
Oh,
Kind of looks like sine and cosine to me. Kind of. Because the you can make some common denominators, and then I think some things will drop out. Just kind of a guess. But you're gonna essentially have on the bottom here, really similar. Sorry, cosine t over sine t. Okay, and then you can make the bottoms the same in both. So that would be my recommendation. Do you know what I mean? Do you know what I mean by that? Each bottom the same.
Yeah.
Okay. So like in the top, you're going to multiply by sine t, cosine t, same thing on the bottoms. So we got sine, sorry, let me get the numerator. Sine squared t, cosine t, sine t. Sine t, sine squared t plus a lot of rewriting, everything's kind of the same, but
Um, can you combine them?
then yeah, we
Wait,
combine the numerators in both. So it's sine squared t minus cosine squared t over sine t cosine t. That's the top, all over sine squared t plus cosine squared t over sine t cosine t.
hmm. Fine. But the denominators cancel.
They do, yeah.
Yeah.
So we got sine squared t minus cosine squared t over sine squared t plus cosine squared t. Do you see anything else?
The sine squared t is equal 1, right?
Give me a little more information. What do you mean by that?
You'd split the fraction.
Just focus on the bottom, just the bottom.
Oh,
That's an identity.
oh, that would just equal 1.
Yes. Okay, so you're down to this, which is great. It's good to kind of keep, in mind again, like where you're going to. This is where it's probably a good idea to look at the left side, see if you can do anything with it. Excuse me. And you can. There's a lot here, but
Um,
and again, do you see how there's two terms on the right and there's could be two terms on the left?
yeah, you could divide everything.
Yeah, so tangent squared t over secant squared t. And this is where you get excited. You're like, okay, 1 over secant squared t, that's cosine. That's really good. So we've got that part. And then does this left one become sine squared t?
Hang on. Secant. Yeah, because the tangent equals sine over cosine, and then the bottom is 1 over cosine, and then the cosines cancel, so it's sine squared t plus or
Right.
over 1.
Right. And your teacher probably wants to see that, like you're not just supposed to write that they're the same, but you just said everything that is true. Sine squared t minus cosine squared t. And you got it. Just a few comments on 66 here. Let's see what this one has. Is it 1 plus cosine x on the right? Does that finish that off on the right?
Yeah.
Okay, great. I would suggest multiplying these out on the left. And on the right, doing the same thing, doing the actual multiplication. So on the left, I'll do the one on the left because it's a little harder. You get 1 plus sine x plus cosine x. And then you get a sine x, sine squared x, sine x cosine x. And then you get a cosine x, sine x, and a cosine squared x. And so when you add all this up, you get a 1 plus 2 sine x plus 2 cosine x plus sine squared x plus cosine squared x plus 2 sine x cosine x, like that. And this middle one becomes 1. So this right here becomes 1. So you end up getting 2 plus 2 sine x plus 2 cosine x plus 2 sine x cosine x. And if you FOIL over here on the right and then multiply by 2, you will get this one on the bottom.
Oh, can you remind me what FOIL is with it?
Just first, outer, inner, last. So 1
Oh,
times the 1, sine times the 1, so on.
Oh.
Hey, I got to run. We'll let me know if you need a lesson money, but that is it. I'll see you next time.
all right. Thank you.
You're welcome. Bye now.